Alright, today we are going to look at a new MCP server for pycse that I have integrated into Claude Desktop that provides some design and experiment capability. So I'll show you how I install it later. If you click on this little button here, you can see that we have Claude Light. That's a tool I talked about before. It's a separate MCP server that communicates with Claude Light. You can see Claude, let's see, over here. So this in the bottom right corner is the Claude Light instrument sitting on my desk. And that one allows me to either run it or get some information about it. And you can also see now there's a pycse set of tools, and we're going to focus on these SR commands. That's a surface response design of experiments. So what this set of tools allows me to do is, in natural language, I can say use pycse to create a surface response design of experiments for Claude Light, where the red, green, and blue channels vary from, let's say, 0.2 to 0.8. And we'll measure the 515 nanometer. Let's just say we measure a green light channel. And let's see what this does. So what this should do is call one of those tools, and here it is parsing out the design SR, so it's figured out what the outputs are, and it's going to make some factorial points, some center points, and it doesn't really tell me what those are. Let's see if it can show me. Alright, so here you can see how it's varying from 0.2 to 0.8. Alright, let's say go ahead and run those experiments with Claude Light. So pay attention to this bottom right corner. See how it just turned on? You can see it's actually running experiments, and every time it blinks over here, it is running one of these experiments. You can click on this arrow, you can see here's the output. This is an actual output from Claude Light. So it's just running through and running those experiments right now. And that's working because it's able to parse the RGB and call the RGB tool, which communicates with Claude by a REST API, and then it gets the data back, and Claude Desktop is able to capture that. And over here it says to run the analyze surface response, so we'll try that next. So it's able to recognize the 515 nanometer channel as green light. Now it's rewriting our table to include the results, including some replicates. All right. Now analyze those results and show me the analysis. So it's gone through all of this results and pulled out the inputs. Here it's asking me to use the SR parity plot. That's because it's a tool and it's running locally. It looks like that didn't quite work, but the analysis did, so it's able to find a very good model. It gives me some intercepts. Let's wait for it to run. even does some interpretation. So the green channel input has the biggest effect on the green output. That's no surprise. That it is highly linear. Blue channel has a minor effect. Red channel has a negligible effect. So the blue channel evidently overlaps a little bit, barely, but significant. And the red channel is just in the noise, no interactions. And here is a simplified equation for predicting the blue out or green output. So that's pretty interesting. Like overall, we're able to leverage the Python libraries in pycse to do a design of experiments, set up the design, implement it with Claude Light, get the data. You could also probably enter the data manually, so you might save this data, save the experiments, run them offline, and then put them back in so that you could do the analysis that way. Maybe it's worth talking out now how that happens. So here is the MCP server that's running locally that gets installed. So we just make an MCP server here. It's named pycse. It's a little bigger so it's easier to see. And I'll skip through. This is a Latin square design. Let's scroll down here to surface response, and this is where all of the magic in this happens. So I use Pydantic here to define the inputs. So here we have a list of strings that represent the inputs, the variable names, another one for the outputs, and the bounds. Here we have one bound that's a float and a float, so it's a tuple of min and max, and then we have a list of bounds that we have to define. So these Pydantic classes are actually really crucial for the model to be able to take your natural language and convert it into the inputs that go into this function. So we have 3 required variables to design our surface response: the input names, the output names, and the bounds. And all that does in here is create a surface response class using these variables, and then call the design. And then I store this kind of global state so that we can reuse this between calls. I don't love that, but it's okay. So that's all that happens, is this returns a pandas data frame of the design, and then Claude Desktop does the rest in terms of formatting it. Now, once you get the results, we specify a Pydantic class for a result, and the result is going to be for an experiment number, and it's just a float. So I only support one variable in this DOE proof of concept. And then you get a list of those results, and you need that for analyzing the surface response. And so again, this set of Pydantic classes is how Claude Desktop is able to parse the text that it gets into structured data that we can use in the analyzed surface response. And all we do here is set the outputs and call the fit function, which is part of an established library. And then we return a summary, which just is a analysis of variance string. And then this parity plot doesn't seem to work right now. I'm not sure what the problem is. In theory, it should present an image of the parity, but it doesn't work 100% all the time. So that's basically how the tool for the surface response works. There is also this help function, so pycse help will get all of the doc strings for all the function names and return that to Claude, and you can use that in the following way. I'm going to hide this again and say, tell me what pycse can do for me. Now, without this tool, it would have to do some web search, and maybe it would find it something on the web from the GitHub page or the documentation. This is coming directly from the version of pycse that you have installed. So it is, it's a little bit interesting. So these are actually functions that are in the MCP server, but these other ones are all functions that exist in the pycse. And so you can use this as a way to kind of get an overview of what's possible. Okay, in terms of getting this installed, MCP servers are a little script that gets run on your computer, and you have to register it with Claude Desktop, and then it will launch the server when you start it up. And so you register it by editing this desktop config.json. And it exists in different places if you're on a Mac or on Windows. But basically you just need to add a configuration to it, and the configuration is down here. You have to add a pycse section, and then you have to set up a command. And so I run pycse MCP as a function that maps to this main, and that's now part of pycse. So when you install pycse, you get this pycse MCP server. And so this function does kind of 3 different things depending on how you run it. If you just run it, it launches the server. If you give it an argument of install, it modifies the desktop config. And if you do uninstall, it deletes that from the desktop config. And I don't know if I love that, having 3 different things in one function, but it makes it pretty straightforward to do. So here is the uninstall. It just deletes the pycse configuration and rewrites the file. So, okay, so that's all this video is about, is kind of demonstrating this proof of concept that you can take a Python library and set up some Pydantic classes for structured data extraction from the prompts and the outputs, and have that call tools like a design of experiments and do analysis. There's still maybe a lot to be desired about, the whole integration. Let's say it took a long time to do the experiments, you'd probably want to save the design somewhere so you could reload it, for example, and I haven't worked out many of those kinds of details. And otherwise, it seems like a pretty interesting proof of concept idea in terms of expanding the capability of a LLM desktop. Now, Claude Desktop's the only one I know that is easy to plug in these MCP servers. I don't think you can do this yet easily with ChatGPT. You can, of course, write your own kind of client for this, but the whole point of it for me was to leverage an existing client. So that's it for today. Hope you found it interesting, and you can install this from pycse now, and